All right. As the previous two examples illustrated, if the integral we want to evaluate can be made to match one in the table exactly, then evaluating the indefinite integral consists simply of substituting the correct values of the constants into the formula. But what if we can't actually match the integral with one in the table? So what we're going to have to do in a lot of cases is actually do a substitution to change the given integral into one that actually corresponds to something in the table. And so that's going to make it a little bit harder, but it's not going to be impossible. So let's try this one. So we have the square root of 9x squared minus 16 dx. All right, so if we go back to share the table, so that one we need something like a squared and then a minus b squared, but it's going to be in the numerator, not in the denominator. So let's keep going. So if we go to the next page, what's it show? Oh, here we go. AU squared minus a squared, and it's going to give us this long drawn out equation. Okay, so that's what we'll use. And so here we're going to use number 40. Maybe I should have been writing these down as I've been going, but I forgot to. So we're going to use number 40. And first things first, this isn't really in that form. What we have to think about there is, well, what do we have? Well, u is really going to be a 3x because if we square that, that'll give us 9x squared. And so what does x equal then? Well, that equals 1/3 u. Okay. And so because of that, what I'm going to say this integral now is really 1/3 the integral of square root of 3x squared minus 4 squared dx. So now that puts it more in the form of what we know as far as the function number 40 goes, or the equation 40 goes. So because of that, I'm going to have now, I probably need more room, so I better put it over here. We have that 1/3 times, and now our number 40 says, okay, well now we have 1/2 times 3x, which was our piece here, and then times the square root of 9x squared minus 16. And then we're going to have a minus, and then we'll have our that squared, so it's going to be 16. And then we have ln of 3x plus, and then we have square root of 9x squared minus 16. And then we have a parenthesis and a parenthesis, and then we have a plus c. Okay, so any simplification here looks like really the only thing we can do is multiply those. So that gives us 1/6, and then we have what? 3x square root of 9x squared minus 16 ln of 3x plus square root of 9x squared minus 16, and then plus c. Okay, and that's supposed to be a not just a parenthesis. Those are absolute values. That's an absolute value, so this one has to be absolute value. Got to make sure I put all the right things here. I just noticed that, that, and then we can put parenthesis. So then that one closes that one, and then we'll have another one here. All right, now it looks more right. Okay, so then that would be our final solution to this one. That's as far as we can go as far as taking this integral. And the only other thing we could have done is, okay, well, what if we had gone from 1 to 4 or whatever it was? Then we could actually evaluate that one. All right, so let's stop there. We can come back for some more.